So it's my video for a linear algebra course, final project. My topic is wavelet transformation and SVD that we will use for an image compression. So let's first start with the wavelet transformation. A wavelet is a function which shows the change of a frequency in a time, and it can be used for an image compression. It's one of the most popular way to compress the image. There are many wavelets, mother wavelets. I will write a formula of a mother wavelet. It looks like that. And this formula shows how we can calculate each wavelet, but there are some common, most popular wavelets. The wavelet that we will use in our project called Haar wavelet. It's a function that can be written like that. It's equal to 1 when the time of our function is from 0 to 1/2, and it's equal to -1 if our time is lying between 1/2 and 1. It can be shown like that, like this figure. And then let's talk how we can use it for image compression. Actually, we have an image that is a matrix, and then we want to make it in another basis. Firstly, we have it in a standard basis, but we want to describe it in other bases. First, I will write for a 2x2 matrix because it's a good way to describe what I mean. We have 4 matrices here, and if we are talking about 4x4 matrices, it would be 16 matrices, and so on and so on and so forth. The main idea is that our basis matrix save some part of our details. Like, firstly, we would take just an vertical elements, diagonal elements, only horizontal elements, some squares of a matrix, and so on. And by that, we will form this basis matrix. As we know from a linear algebra course, when we want to make a matrix in another basis, we will have some coefficients near this matrix. And actually, the idea of compression is connected with these coefficients because we just take the coefficients and we make a new matrices of our image based on these coefficients, and we can choose the the biggest one by the model, by the absolute value, and other values we can make as a null. And in this case, we will have a compressed image in that strongest of compression that we need. So I have written for a 2x2. We can see 4 matrices with the coefficients, and then we will try to make it with I will describe you how to make it with bigger matrices, 4x4, for example. Actually, we have two ways to do it. One is the way by the definition that I have already described to you. It's to understand it logically, that these matrices save some parts of it. For a 4x4, it would be a matrices with ones on the first two horizontal parts and -1 on the second two. The same with diagonal, with the vertical ways, but in our project we use another method because it's a bit easier for a computer language, for a machine learning. We have used a Knocker product. I will describe to you what does it mean, because we haven't covered it in our linear algebra course. Knocker product is like showed by this sign. And how it works. We have matrices A, for example, with two vectors 1, 2, 1, 2, and the matrices B, for example, I don't know, 1, 3, 1, 3. And how we would use this Knocker product to, what would it give to us? If we write like that, A Knocker product B, we will just take, we would get from a 2x2 matrices, we would get a matrix 4x4, because we just, okay, I'll write it. The new matrices will be formed by this multiplication, where each element of A it's multiplying as a scalar to the matrix B, and from that, from a 2x2 matrices, we will get 4x4 matrix. So I will take a notion that in our project we used such a method. We have two methods. We can or subtract some values and make a matrix with the size that is like can be divided by 2, or we use the method when we add zeros, just because it's do not ruin the image. So how we use Knocker product to calculate the matrices in our project? For each size we have some base matrix. We started with H2 for a 2x2 matrix. It's matrix with two vectors 1, 1 and 1, -1, and the identity matrix the same size 1, 0, 0, 1. Like identity for 2x2 matrices. And the way we calculate the base matrix for H4, for example, it's we just made a Knocker multiplication H2 matrix by identity matrix. As I have already mentioned, we would get a matrix that is a size 4x4, and then we can use this matrix and calculate each our basis matrix for this size, how it would looks like. For example, H0, 1, it would mean that we take from our matrix I would say that we calculate from A0. So we would take the 0 column and multiply it by first row transposed.